Hello all, welcome to Brilliant Coaching Classes. I am Nilima Patil. In this video, we are going to start chapter number 3, Understanding Quadrilaterals. First, introduction. See, plane surface. Paper is a model of plane surface. So the paper which you use for writing is an example of plane surface. Even this writing board is an example of plane surface. The flooring of this room is also a plane surface. The tabletop is also an example of plane surface. Now what is plane curve? When you join a number of points without lifting a pencil or pen from the paper or this board and without retracing any portion of the drawing other than single points, you get a plane curve. See, if I get some points on this board, so these are the points. Now I start from here and join all these points. So here, then I come here, then here, then here, and then here. So without lifting this pen, I joined all these points, and now this figure is a plane curve. Even this is a plane curve. Even this segment is also a plane curve. This is also a plane curve, because to draw this also I did not lift the pen. I started from here and it ends here without lifting the pen. So this is also a plane curve. Now see, if you draw the figure like this, this is also a plane curve, because here also I did not lift the pen. I started from here, then went here, here, and then here, and it ends here. So this is also a plane curve, and here these two segments are intersecting in one point. Even then this is a plane curve, because here it is given without retracing any portion of drawing other than single points. So you can retrace a single point, even then it is a plane curve. But if I draw a figure like this, if I start from here, now without lifting I drew this, then I'll draw this, I'll draw this, then I'll draw this and this. Now I want to complete the below portion also, the curve, and for that I need to lift the pen and then I'll draw this. So this is not a plane curve. This is not a plane curve, because here I lifted the pen and then I completed this figure. So this is not a plane curve. Sometimes the same figure we can even draw like this, and that time we retrace a segment. So if I do this, then here, then I come here, then I go here, then I come here. Now to complete this portion, I have to retrace this segment and then I can complete this figure. So this portion is repeated, and therefore this is also not a curve. So here I lifted a pen, here I retraced this segment. So this is not a plane curve. These are all plane curves. Even circle is a plane curve. Circle, or you can say triangle, are plane curves. Triangle is also a plane curve, because without lifting our pen we can complete this figure. So this is about plane curve. Now we will see the types of curves and will match these types with these figures. So first type, simple closed curve. Now what is simple curve? In simple curve, nothing overlaps. Even not the single point is overlapping and not the segments. And what is closed curve? In the curve where the starting and ending point is same is a closed curve. It means we don't know exactly where it starts and where it ends. Like here in the circle, if you start from here, drawing the circle, you again come here. So now here this is the starting point. You can even start from here. So this will be starting point and even the ending point will be same. So we don't know exactly from where this circle has started. So simple means nothing is overlapping, and closed it means the starting and ending point is same and we don't know exactly where it starts. So simple closed curve is this circle, that is number 3. So A and 3 will match. So we can write here A, or here we'll write figure number 3. Figure number 3 is a simple closed curve. Simple, it means nothing is overlapping here, like this. Here it is overlapping, here it is overlapping, like this. Cross is here. In this figure, nothing is overlapping, so it is a simple curve, and it is also a closed curve, because if you take this as a starting point and you complete the circle, the end point is also there itself. If you start from here, then the end point will be there only, and we don't know exactly where is the starting point. So this is the simple closed curve. Next, a closed curve that is not simple. Now, closed curve, it means the starting and end point is same, and not simple, it means it must be overlapping. Now see in this figure 4, it is a closed curve. Why it is closed curve? Because its starting and ending point is same. If you start from here to draw this figure, if you start from here, we'll go till here, then come here, and again will come at the starting point. So the end point will be there only. So starting point and end point is at the same place, and we don't know where exactly it starts. You can even start it from here. So if you start from here, so you'll draw like this, come here, and again you will end here. You can even start from here. If you start from here, then you'll draw like this, and you'll come here again. So this is a closed curve. Now it is not simple. Why it is not simple? Because this point is overlapping. Here it is a cross. This point is overlapping. It is retracing. So this is not a simple curve, and therefore this figure matches with this. A closed curve. It is a closed curve because we don't know the starting and ending point, and even the starting ending point is at the same place, and it is not simple because this point is retracing. Here it is overlapping. So B matches with figure 4. Now C, simple curve that is not closed. Now simple curve, it means not overlapping. So here it is not overlapping and it is not closed, because see, the end point and starting point is separate here. If you start from here, then you will draw like this, and you will end here, or you will start from here and you will end here. So starting point and ending point is not touching each other, it is not retracing, it is not overlapping. Therefore this is a simple curve, and it is not closed. Points starting point and ending point is different, so it is not closed, and simple curve because nothing is overlapping here. So figure 1 matches with this. Next, not a simple curve. Now simple curve, it means nothing is overlapping, but here it is overlapping. Here it is overlapping. This point is retracing. Therefore it is not a simple curve, and this figure 2 matches with D, not a simple curve. So this is about the types of curves. Once again I tell, simple it means nothing is overlapping, and closed curve it means the starting and ending point is same, and you don't know where exactly it starts, but wherever it starts, it will end there only. So that is a closed curve. Now we will see what is polygon. A simple closed curve made up of only line segments is called a polygon. Now see this figure, it is a simple curve because nothing is overlapping here. It is also a closed curve because its starting and ending point is at the same point. If you start from here, then we can draw like this, then we come here and here it will be the end. So starting and ending point will be at the same point, and you can start at any point. If you start from here, then you will go here, come here and you will complete the figure. So again the starting and ending point will be at the same point, and we don't know exactly where it starts. So it is a closed curve. This is a simple and closed curve, and this is made up of line segments. So here these are 4 line segments. So this is a polygon. This figure is called polygon. Now see here, this is also a simple closed curve. So this is also a polygon. It is made up of only line segments. Same here, this is also a simple closed curve and it is made up of line segments. So this is a polygon. Even triangle is also a polygon. This is a simple closed curve and this is made up of 3 line segments. So this is a polygon. But see, circle. Circle is a simple closed curve. This is a simple curve as well as it is a closed curve, but this is not made up of line segments. Therefore, this is not a polygon. Circle is not a polygon. Now, see here, these are also not polygons. Why they are not polygons? This is not a simple closed curve. Though this is made up of line segments, but here these segments are overlapping. So this is not a simple curve. Same here, the segments are overlapping. So it is not a simple curve. And here nothing is overlapping, but it is not a closed curve. It is simple, but it is not a closed curve. So this is also not a polygon. So these curves are not polygons and these curves are polygons. Circle is not a polygon, though it is a simple closed curve, but it is not made up of line segments. So circle is not a polygon. Now let us study classification of polygons. We classify polygons according to the number of sides or vertices they have. So how many sides or how many vertices the polygon has, accordingly we will classify it, we will name the polygon. Now see, if the number of sides or number of vertices are 3. So for the polygon, if there are 3 sides, there are 3 vertices, then we name that polygon as triangle. We call it as triangle. 3 sides, 3 vertices, so that is a triangle, and we can draw a figure like this. So 3 sides and 3 vertices. So first, second, third, 3 sides and 1, 2, 3, 3 vertices, and this is a simple closed curve. Therefore, this is a polygon, and here number of sides are 3, number of vertices are 3. Therefore, this is called triangle. Tri means 3. Next, if the polygon has 4 sides or 4 vertices, then it is called quadrilateral. Quadrilateral. We draw the figure like this. So this is a 4-sided figure with 4 vertices. This is a quadrilateral. It is a quadrilateral 4-sided figure. This is a polygon because it is a simple closed curve with 4 sides, 1, 2, 3, 4 and 4 vertices. So it is a quadrilateral. Now in this chapter you are going to study about this quadrilateral only. Next, if the polygon has 5 sides, 5 vertices, then it is called pentagon. It is called pentagon. Penta means 5. See, tri means 3, quadra means 4 and penta means 5. So this is pentagon. Now the figure is 5-sided figure. So 1, 2, 3, 4, 5. This is a pentagon. It is a 5-sided figure and this is a polygon. Next, if 6 sides are there, then it will be hexagon. So we'll draw that figure. 6 sides hexagon, 7 sides heptagon, 8 sides octagon, then 9 sides nonagon, 10 sides decagon. See, we saw the last pentagon. Now 6-sided figure, 6-sided polygon is hexagon. Hexa means 6, hexagon, 6-sided figure. So 1, 2, 3, 4, 5, 6. This is a hexagon, 6-sided figure and 6 vertices are also there. Next, if the number of sides or vertices are 7 for any polygon, then it is called heptagon. Heptagon. This is a 7-sided figure. 7 sides. So 1, 2, 3, 4, 5, 6 and 7. Heptagon. 7 sides, 7 vertices. So this is a heptagon. Next is 8-sided polygon. It is called octagon. 8 sides. If number of sides are 8, number of vertices are 8, then it is called octagon. Octa means 8. Now how to draw the figure with 8 sides and 8 vertices? 1, 2, 3, 4, 5, 6, 7, 8. So this is a octagon, 8-sided figure, 8 sides and 8 vertices are there. 1, 2, 3, 4, 5, 6, 7, 8. Total 8 vertices are there. It is octagon. Next, if 9 sides are there and 9 vertices are there to the polygon, then it is called nonagon. Nonagon. 9 sides. How to draw the figure with 9 sides and 9 vertices? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 sides are here. 9 sides and 9 vertices, it is nonagon. Next is 10-sided polygon. 10 sides and 10 vertices. We'll draw the figure for that also. 10 sides. So this is decagon. Decagon. Now 10-sided figure. We'll draw here 10 sides and 10 vertices. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a 10-sided figure. Now vertices are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are 10 vertices and there are 10 sides. So this is a decagon. This polygon is called decagon. It means if there are n sides, number of sides, it can be 11, 12, 20, whatever. So if n sides, then we call it as n-gon. N-gon. Deca means 10, so decagon. 9 is nonagon. 9. 8 is octagon. So like this is the classification of polygons. You can remember till 10. That is also sufficient. And in this chapter, you are going to study the quadrilaterals in detail. Quadrilateral is a 4-sided figure with 4 vertices. Next, we will see what are diagonals of a polygon. A diagonal is a line segment connecting two non-consecutive vertices of a polygon. Now see here, already I have drawn 3 different polygons. Now this first is a 4-sided figure. It is a 4-sided polygon. It is a quadrilateral. Now here, line segment connecting two non-consecutive vertices. If you see vertex P and vertex Q, these are adjacent vertices. Then vertex P and vertex S are also adjacent vertices, but P and R are not adjacent, they are opposite and they are non-consecutive. Consecutive are this, which are adjacent, those are consecutive. So P and Q are consecutive, P and S are consecutive vertices, but P and R non-consecutive vertices. So if you draw a line segment connecting these two non-consecutive vertices, then this is a diagonal of that polygon. So here segment PR is a diagonal. Same here SQ. If you draw this line segment SQ, then this is also a diagonal of this quadrilateral. This point S and point Q are also non-consecutive vertices. P and Q are consecutive. If you join these two P and Q, then you get a side of this quadrilateral. So this is a diagonal which I drew in blue color. Now see here, it is a 5-sided polygon, so it is a pentagon. And here A and B, vertex A and B are adjacent, B and C are adjacent. So which are non-consecutive? A and C are non-consecutive because this is consecutive. Consecutive means it comes immediately after this A. Then C comes immediately after B. So these are consecutive. A and B vertices are consecutive, B and C are consecutive, C and D are consecutive, D and E are consecutive, A and E are consecutive, but A and C non-consecutive. So if I join this vertex A with vertex C, then I get this diagonal AC. Similarly, I can join A and D, then I get one more diagonal of this pentagon. Then B and E can be joined, we get one more diagonal. Join B and D, you get another diagonal. So here we got these diagonals which I showed in blue color. So diagonal is a line segment connecting two non-consecutive vertices of a polygon. Now see here, this is also a polygon which has 4 sides. Now here L and M are consecutive vertices, M and N are also consecutive, but L and N vertex are non-consecutive. So we can join them and we get the diagonal here. So Ln is the diagonal. Same N, K are adjacent, K point and L point are also adjacent vertices or consecutive vertices, but vertex K and vertex M are non-consecutive. So if we join them, if you connect them, then the segment KM is also a diagonal. So this is how we draw diagonal for the polygons. Next, we will study about convex and concave polygons. Which are convex polygons? If the diagonals of the polygon are in the interior of the polygon, then those are convex polygons. See here, in these figures, all the diagonals are in the interior of the polygon. These are the diagonals which are in the interior of the polygon. So this is a convex polygon. Same here, if you draw the diagonals, these are in the interior of the polygon. Same here, diagonals are in the interior of the polygon. Here also if you draw the diagonals, these are in the interior of the polygon. So many diagonals you can draw here. So these diagonals are in the interior of the polygon. Here also. So these polygons are called convex polygons. These are convex polygons because all their diagonals are in the interior of the polygon. Now, what are concave polygons? If the diagonals of the polygon are in the exterior of the polygon, then those are concave polygons. See here, if I draw the diagonal, now this is the diagonal and it is in the exterior of the polygon. This diagonal is in the interior of the polygon, but one diagonal is in the exterior of the polygon, so this is a concave polygon. Same here, this diagonal is in the exterior of the polygon, so it is a concave polygon. This will be in the interior, this is in the interior, this diagonal is in the interior, but this diagonal is in the exterior, outside of the polygon, so it is a concave polygon. Same here, this diagonal will be outside of the polygon. Here also, this diagonal is in the exterior or outside of the polygon, so these are all concave polygons. One more thing, in concave polygons, one of the interior angles is more than 180 degree. If you measure this angle, it will be more than 180 degree. So these are concave polygons. This angle will be more than 180 degree, which is the interior angle of this polygon. So this is a concave polygon. Here also this angle will measure more than 180 degree. Even here this angle will measure more than 180 degree. Therefore these are concave polygons. So this is one of the property of concave polygon. Their interior angle, one of the interior angle is more than 180 degree. And here in convex polygons, each angle measures less than 180 degree. If you see, this angle will be less than 180 degree, this will be less than 180 degree. All these angles will be less than 180 degree in convex polygons. So this is about convex polygons and concave polygons. Now let us study regular and irregular polygons. A regular polygon is both equiangular and equilateral. Equiangular, it means all angles measure will be same. All angles measurement is equal. And equilateral, it means all sides measurement is equal. It is same. Now see these figures. First is a triangle where all angles are shown with the same marking. It means measurement of each angle is same. All the angles measurement is equal. Therefore this is equiangular, as well as all the sides are shown by the same marking. This side and this side are shown by the same marking. Therefore this figure is equilateral also. It means here this figure is equiangular as well as equilateral. Therefore this polygon is regular polygon. Same here, this is a four-sided polygon. It is a quadrilateral. Each angle is shown 90 degree. So all angles are of equal measure and even sides are shown by the same marking. Therefore all sides are same. Measurement is equal. Therefore this polygon is equiangular as well as equilateral, and therefore this is a regular polygon. Same here, the angles are equal and sides are also equal. So these figures are also equiangular as well as equilateral, and therefore these are also the examples of regular polygons. Now see here, in this triangle one angle is shown 90 degree but other angles is not shown, or 90 degree or any number is also not given. So measurement of those two angles will be something different than 90 degree. It means these angles are not of equal measure, so this is not equiangular. And sides also are not shown by same marking, so sides are also different measurement. Therefore this figure is not equiangular as well as it is not equilateral, and therefore this is irregular polygon. But now see in this figure, here all the four angles are shown 90 degree each. It means it is equiangular. All the angles are equal, all 4 angles in this figure are shown equal. So this is equiangular, but it is not equilateral, because see, these two sides are shown by the same marking, so they are equal to each other, and these two signs are shown by the same marking and they are equal, but they are not equal to these two sides. So these two sides are equal, these two sides are equal. It means all the 4 sides are not equal, therefore this is not an equilateral figure or polygon. Therefore this is a irregular polygon. So both conditions should be satisfied in the figure for to be a regular polygon. Here only one condition is satisfied of angles equal but sides are not equal, therefore this is irregular polygon. Now in this figure all angles are also different, only these two are same 90 degree each, and these two sides are same but these 3 sides are different, therefore this is not an equiangular and not an equilateral, therefore this is also irregular polygon. And same here, the angles are shown different, 4 angles are same but other 2 angles are different than these 4 angles, though they are equal to each other. Sides also, these 2 sides are same but other 4 sides are same but which are different than these 2 sides. So this figure is also not an equiangular as well as not an equilateral, therefore this is also irregular polygon. So this is how you can identify regular polygon and irregular polygon. Regular, it means it should have equiangular and equilateral condition, it should satisfy that condition. Next, angle sum property. Already you are aware of this property, sum of the 3 angles of a triangle. The sum of the measures of the 3 angles of a triangle is 180 degree. Sum of the 3 angles of a triangle is 180 degree. It means here angle P plus angle Q plus angle R is equal to 180 degree. It is a triangle, there are 3 angles, sum of the 3 angles is 180 degree. Now using this property we can find out the sum of 4 angles of this quadrilateral. This polygon has 4 sides, 4 vertices, 4 angles. This is a quadrilateral. See, if we draw BD, then this quadrilateral will get divided into 2 triangles. So this will get divided into 2 triangles because of this segment BD. Actually it is the diagonal of this quadrilateral. Because of this diagonal BD, this quadrilateral ABCD got divided into 2 different triangles, and we know that sum of the 3 angles of a triangle is 180 degree. So here there are 2 triangles. Using that property we can find out sum of all the 4 angles of this quadrilateral. So here this is angle 1, this is 2, 3. Next 4, 5 and 6. Now see, first angle A. We know that angle A plus angle B plus angle C plus angle D. So if you add these 4 angles, we can find sum of 4 angles of this quadrilateral. Now see, angle A is angle 1 plus angle B, it is 2 plus 4, this is complete B. So it will be 2 plus 4. Then these are all angles, angle 1, angle 2, angle 4. Then C is here angle 6 and D is together angle 3 and 5. So this is angle 3 plus angle 5. Now see, 1, 2 and 3. So this 1, 2 and this 3 will bring together angle 1 plus angle 2 plus angle 3. Next, angle 4 plus angle 6 plus angle 5. Now if you observe this 1, 2, 3. So here 1, 2, 3, these are the 3 angles of this triangle ABD, and sum of the 3 angles of the triangle is 180 degree. Same 4, 6, 5. This is 4, angle 6, angle 5. These are the three angles of triangle BCD. This triangle BCD. Now sum of the three angles of a triangle is 180 degree. So sum of these three angles is 180 degree. Now 180 degree plus 180 degree is 360 degree. It means sum of the four angles of quadrilateral ABCD is 360 degree. So this is the angle sum property of the quadrilateral. Sum of four angles of any quadrilateral is 360 degree. Thank you.